Good day, viewers. You are
Beautiful day,
welcome to
welcome.
today's
Don't
math
stop
class.
learning.
So, there's a difference between an exponential equation and a tetration. For instance, you have 3 tetrated to 3 is equals to 3 raised to the power of 3 raised to the power of 3. And we know that 3 raised to the power of 3 is equals to 27. So, 3 raised to the power of 27 is what? You know that this is going to give us a bigger number. You can press that in your calculator. But if it was 3 raised to the power of 3, you can see that we all know that 3 raised to the power of 3 is equal to 27. That's why most people used to call this tetration a superpowers, because the value is always higher than that of exponential equation. So let's solve this question. Firstly, do you know that you can equate the base? You can equate this base because 3 raised to the power of 3 is equal to 27. But to equate this base, we are going to need to change this to tetration. How do we do that? You know that 3 raised to the power of 3 is equals to 27. So let's change this exponential equation to tetration. It is equals to 3 tetrated to 2, because we can write 3 tetrated to 2 as 3 raised to the power of 3. That's 2 times, and is also equals to 27. Therefore, 27 can be written as 3 tetrated to 2. So here now we have 3 tetrated to 2. So the base are now equal. Therefore, cancel out the base, which is 3. We have we are left with s tetrated to 2 is equals to 2. So now let's change this to an exponential equation. S tetrated to 2 means s raised to the power of x, which is equals to 2. Now to solve this question, don't forget we are going to be using Lambert W function. And firstly, we have to take the ln of both sides, that is the natural logarithm of both sides. So we have the natural logarithm of s raised to the power of s is equals to the natural logarithm of 2. So using the property which says the ln of a raised to the power of n is equals to n times the ln of a,
Subscribe.
which is
Thank
this.
you.
So we are using the property here. We have x times the ln of x is equals to the natural logarithm of 2. And also recalling this property of Lambert W function, we say W function of a times e raised to the power of a is equals to a. That is, if you have same number multiplied by e raised to that number again is equals to that number. So using this property, before using it, let's take the Lambert W function of both sides. And also, okay, and also let us to know this property, which is the natural logarithm of s of base e raised to the power of s is equals to x, because the natural logarithm is going to cancel e, so we are left with s. That's what we are going to use here. We are using all these two properties now. So let's start with this. We have the natural logarithm of s base e times the natural logarithm of x is equal to the natural logarithm of 2, because if you cancel this we are going to get our s back. So now taking the Lambert W function of both sides, we have the Lambert W function of the natural logarithm of s times e raised to the power of the natural logarithm of x is equals to the natural log W Lambert function of the natural logarithm of 2. So using this property, we know that this is equals to the natural logarithm of s, and we have W Lambert function of the natural logarithm of 2. So to eliminate the natural logarithm, we take the e of both sides. So this cancel this. We have x is equals to the e raised to the power of w Lambert function of the natural logarithm of 2. So the answer, you know that the answer is approximately equals to 1.56. Using your super calculator to calculate this, or go to Wolf Armstrong to calculate this, the answer is approximately 1.56. I
To
think
watch
so.
more, subscribe.
So guys, we have come to the end of the class. Please don't forget to subscribe, like and share. Bye bye.